Welcome to this Scicom Machine Learning 2 tutorial. In this session, we'll tackle a multi-class, multivariable classification using gradient boosting classifier. I'll introduce the Alzheimer's disease dataset we're using, summarize the input features and target value, explain at high level how gradient boosting works, and then show how we split, train, and evaluate the model. This slide summarizes the columns in the Alzheimer's dataset. Each column is a patient's attribute we can use for prediction. For example, demographics like age and gender, lifestyle indicators such as smoking, alcohol consumption, physical activity, diet quality, and sleep quality, and clinical factors including family history of Alzheimer's, cardiovascular diseases, diabetes, depression, head injury, hypertension, blood pressure, and cholesterol. Together, these features provide the multivariable signal we will use to classify patients. Here, we call out two things explicitly: the input features, the patient attributes listed on the previous slides, and the target variable, which is the Alzheimer's outcome class we want to predict. Our learning object is to map from the multi-feature patient vector to the correct diagnostic category, such as no impairment, mild cognitive impairment, or Alzheimer's disease. Now, let's talk about the gradient boosting classifier. It builds an ensemble of shallow decision trees sequentially. Each new tree focuses on the error the prior tree made, improving the fit step by step. Training minimizes a differentiable loss, commonly log loss for classification, by moving in the direction of the negative gradient. At prediction time, the model combines the tree outputs as a weighted sum, and the final class is chosen from that aggregated score. Intuitively, we start with a simple model, then add small corrective trees that progressively reduce mistakes. To assess performance, we split the data, 80% for training and 20% for testing. We train the gradient boosting classifier on the training portion, then generate predictions on the held out test set. For quality, we report the F1 score, which balances precision and recall. Important here because both false negatives and false positives have clinical consequences. In short, train, predict, and evaluate with F1 score to understand how well the model classifies Alzheimer's outcomes. Now let's move on to our web application session. Here, let's use machine learning AI web app to implement this classification model. Now let's name our project first, and then let's give our project a brief description. In the data type section, we choose tabular data as our data type is in CSV format. Then let's upload the dataset. So after successfully uploading the dataset, we can see the brief overview of our dataset. The table tab means all of the columns of our dataset, and the data tab means the summary of our columns. For example, the null instances of all the columns, the data type of all the columns, and the unique values of all the columns. And then let's choose our target label, which is the diagnosis. And then let's click machine learning algorithm. Then let's choose our gradient boosting classification. And then let's use F1 score as our metric. And then let's click perform. So after a few seconds, we can see our F1 score is 0.95, which is very close to 1. That means our prediction is very close to perfect, and means our model fits the dataset very well. Thanks for watching.